So first thing, present value. Well, first of all, let's just write, what are we looking at? What are we worried about? Time value of money. All right. And first thing I want you to know is the equation for present value. I'll just write it out. Present value, PV. The equation for present value equals cash flow divided by 1 plus R raised to the T. Okay, what is R? R is the discount rate. And R could be considered the opportunity cost. I don't get into that kind of level of understanding, but know that this is the equation for present value. Okay, so this probably doesn't mean too much for you yet. So let me set up a scenario here. And what this is going to look like is we are going to be purchasing a building to rent, and I'm going to use just very simple numbers. Okay, they're not anywhere close to real world numbers, but let's say we're going to purchase a building for $1,000, and we are expecting for 3 years to get rents from that building. And the question is, should we take on this investment or not? Okay, well, let's write it out here. We're going to do a little number line, and we're going to say year 0, or right now, we're going to say year 1, year 2, year 3. Okay, and we're talking about present value, the time value of money. We were talking about cash flow. So here's where it's going to come into play. Okay, so we are going to spend $1,000 to buy a building. Okay, and you can consider this a loss because that's something you're spending. But in the future, in year 1, just write the word year. In year 1, we expect to make $350. In year 2, we expect to make $350. And year 3, we also expect to make $350. So the question is this a good investment? Well, you could very simply say, hey, 350 plus 350, that's what's 700, and then 700 plus 350, that's $1,050. Yeah, I'm going to get my money back and $50. That should be a good investment. Okay? Net present value says, let's look at the time value of money. Before we make a decision here. So we had the equation for present value. And what I am going to do is I am going to look at each of these cash flows in the future, expected cash flows in the future, and I am going to discount them back to the present to get the present value of those future cash flows. Okay, so I use this equation we have right here, and I figure out, so the equation is going to be 350 divided by 1 plus r raised to the 1. And then it's going to be 350 divided by 1 plus r raised to the 2. And you can see where the exponents came in. And it's going to be 350 times 1 plus r raised to the 3rd. Okay, so r is unknown. We said that that's the discount rate, and that's going to be a given. Okay, r is going to be given. R is going to be 5%. Okay, you can consider that the cost of money in the current market environment. Okay, so we've got year 0, we're paying $1,000 for the investment. In year 1, we expect to make $350. Then I put this through the present value of cash flow, and I'm going to get 350. This is going to come out to 333. And this is going to come out to 317. And this is going to come out to 302. Okay. It's minus 1,000. So this equals net present value. I am going to erase this right here. This is the figured out, well, not figured out fully yet, net present value calculation. We're looking at the cost for the purchase of the investment vehicle. We're looking at the cash flows in the future, and we're discounting them to the present using the present value formula. And now, when I add everything up, okay, when I add this all up, it's going to equal minus 48. So net present value equals minus 48 with a discount rate of 5%. Okay, so what does that mean? Okay, so you're not going to have to do that equation. You're not going to have to figure that out. But what you do need to know for the exam is if NPV is positive equals good investment. All right. And if NPV is negative, it equals bad investment. You can see we got a negative 48 for net present value. And that says net present value is negative. That's going to be a bad investment. I should not buy that building for $350 payments into the future. Okay, because when I discount those future payments, I'm getting a negative net present value, and that's telling me it's a bad investment. So you're going to have to do something like this on the test. They're going to say net present value is negative. Is that good or bad? Should you take the investment? Net present value is positive. You're going to say that's a good investment. You should definitely take that. Okay? So if you, like, say it was like 800 for net present value, like the initial cost of the building or the investment, this would probably end up being a net positive net present value. In that situation, it would make sense. Okay, but you'd have to do all these calculations to figure it out, and you'd have to figure out the R, which you're not going to have to do. But conceptually, I hope you're seeing it. Okay, conceptually, this is all they care about. Okay, conceptually, you should be able to see that this is present value. All right. Oh, one last thing. It's like it doesn't have to just be a building. It can be a bond, right? The cost of the bond. What are the coupons coming in the future? And I'm going to discount those coupons back to the present value in today's dollars. Okay. So a big high level consideration is money now is greater than money in the future. Okay, so there's one more thing we've got to do, and this is very interesting. We're going to take this equation for net present value right here, and we're going to bring it down. Next thing we're talking about is internal rate of return. Okay, to find the internal rate of return, we are going to set net present value equal to 0. That means we have minus 1,000 plus 350 over 1 plus R plus 350 of the cash flow over 1 plus R squared, R1, and then 350 over 1 plus R raised to the third. Okay, again, you're not going to have to do these calculations, but you can see that we're putting net present value equal to 0. Now that we've put net present value to 0 to find the internal rate of return, okay, we only have one variable that isn't declared. So we've got to solve for R. R is going to be the internal rate of return when we figure this equation out. Okay, internal rate of return, net present value is set to 0. Okay, and if you just want to see where that came from, there's the cash flows. There's where we figured out good investment, bad investment. Now we're looking for internal rate of return, and we're setting it to 0. And we get, when we do all this calculation, and you'll have to use like an online calculator, and again, you're not going to have to do this on the test, we're going to get 2.48%. Okay, equals the internal rate of return. Okay, so with looking at 2.48% internal rate of return, and we know the current opportunity cost out in the market is 5%. Or you could call that the cost of capital. You can see that this investment with an internal rate of return of 2.48% is less than the current opportunity cost. So again, this is just another way of saying that this situation that we queued up here is a bad investment. Okay, so high level, internal rate of return is just like one order down calculation from net present value. Both things are looking at cash flows in the future, and we're discounting them back to the present. Internal rate of return is when we set net present value to 0, and these are all ways to determine if an investment whether it's a bond, whether it's purchasing a building, whether it's purchasing just about anything. Okay, it's using commercial real estate, just regular real estate. Okay, this is a financial consideration. You're not going to have to calculate this, but you have to understand the concepts. So I'm going to go back to the slides and let's see what they have on the slides here. So hopefully that illuminated some things for you. So net present value, the actual calculation says net present value equals the present value. I put in parentheses sum of discounted cash flows. That's when we did the 350, 350, 350. And we discounted them back using the rate of return, the discount rate of the market, and we subtract the initial investment, which was the $1,000, right? Okay. Then we determined that net present value is negative on the example that I queued up, and we determined that this is bad. We should not take that on. Okay. Internal rate of return is the discount rate at which the net present value of an investment equals 0. And that's all you need to know. Okay, that's really what they're going to look for on the test. You might have to push these around just a little bit, but you're not going to have to do the calculations. So let's look at some of that's it. That's the most complicated things on the entire exam.